What if I told you that the icy moon of Jupiter, Europa, could hold the key to one of humanity's most profound questions? Are we alone in the universe? Imagine this. Scientists recently discovered something mind-blowing beneath Europa's frozen surface that has made them rethink everything we know about life. This isn't just a wild speculation or a science fiction plot. It's a possibility that could soon become a reality. The discovery of alien life on Europa would not only change the way we see space, but could fundamentally alter our understanding of life itself. Europa has long captivated the imagination of scientists and stargazers alike. With its icy exterior, it might seem like just another cold, barren moon in our solar system, but the truth is far more fascinating. Europa is one of the most intriguing places in space because, beneath that thick ice crust, there's strong evidence that a vast liquid ocean exists. This hidden ocean is kept warm by tidal forces created as Europa orbits Jupiter. This makes Europa one of the most likely places in our solar system where life might exist, or at least where conditions could support life as we know it. For decades, scientists have speculated that the combination of liquid water, heat from tidal friction, and essential chemicals could create the perfect environment for life to thrive. But until recently, we didn't have any real evidence to support those theories. That is, until the most recent missions, like the Galileo probe and the upcoming Europa Mission, started revealing tantalizing clues. So, what if we found life there? What would it mean for humanity and our place in the universe? The search for alien life has been a cornerstone of space exploration for centuries. Ever since humanity first gazed at the stars, we've wondered whether we're the only life forms in this vast, seemingly infinite universe. The traditional targets for this search have always been planets in the habitable zone, the area around a star where conditions are just right for liquid water to exist. But Europa, with its hidden ocean, is a wild card in this search. It doesn't lie in a traditional habitable zone, yet it harbors the ingredients that could potentially support life. When we think about alien life, we often imagine little green men or giant, tentacled creatures. But life, as scientists understand it, doesn't have to look like what we're familiar with. Europa's ocean could host microbial life, the building blocks of any complex organism. The concept of life could be something much more subtle and different than what we expect. This opens up a profound question. What if life on Europa isn't just different from Earth's life, but truly alien in every sense of the word? Let's take a closer look at Europa's most intriguing feature, the ocean beneath its icy surface. Europa's ice shell is roughly 15 to 25 kilometers thick, but beneath it, scientists believe there's an ocean that could be up to 100 kilometers deep. This ocean is kept warm by tidal heating, generated by the gravitational interaction between Europa and Jupiter. This heating could create the conditions for life, just as the geothermal activity around hydrothermal vents on Earth supports thriving ecosystems deep in the oceans, far away from the sun's light. But Europa's ocean isn't just warm. It could also be rich in the chemical ingredients necessary for life. Organic molecules, essential for building life, have been detected on Europa's surface by NASA's Galileo spacecraft. Furthermore, Europa's ocean is thought to be in contact with the Moon's rocky mantle, potentially providing the necessary minerals and energy sources for life to flourish. In just a few years, NASA's Europa mission will embark on a groundbreaking journey to explore Europa in greater detail than ever before. This spacecraft is set to fly by Europa multiple times, conducting detailed observations of the Moon's surface, its ice shell, and its subsurface ocean. Scientists hope to confirm whether the ocean is indeed capable of supporting life, and, if so, what kind of life might be found. The spacecraft will also analyze the plumes of water vapor that have been detected erupting from Europa's surface. These plumes could provide direct samples of the ocean beneath, giving us a glimpse into the world below. As exciting as this all sounds, the prospect of finding life on Europa isn't without challenges. The Moon's surface is an inhospitable place subject to intense radiation from Jupiter's magnetic field. Yet, even this harsh environment might not be enough to rule out life. If life exists, it may have evolved to withstand the radiation, living deep in the subsurface, protected by the thick ice shield above. The discovery of alien life on Europa would be a momentous event for humanity. It would shatter our long-held assumptions that Earth is the only cradle of life in the universe. The implications would reach far beyond science, challenging our very understanding of existence. If life can thrive in such extreme conditions on Europa, it could suggest that life might be more common in the universe than we ever imagined. It would open up the possibility that life exists in countless other places, not just in our solar system, but throughout the galaxy. Beyond the scientific implications, the discovery of alien life would force us to confront deep philosophical questions. If life can exist elsewhere, what does that mean for our place in the universe? How does the existence of life on Europa challenge religious, cultural, and existential beliefs about humanity's uniqueness? The discovery of alien life wouldn't just be an academic triumph, it would be a profound turning point in human history, one that could reshape how we view ourselves and our future in the cosmos. The discovery of alien life would undoubtedly lead to a wave of new questions. How did life evolve on Europa? Is it similar to life on Earth, or is it something completely different? Would the discovery lead to exploration and colonization, or would we simply observe, wanting to protect the fragile ecosystem of Europa? The journey from discovery to understanding could take decades, if not longer. But one thing is certain. This would be a turning point in human exploration that we would look back on for centuries to come. As we continue to explore Europa, the future of space exploration holds even more exciting possibilities. The Europa Clipper mission will give us the closest look yet at this mysterious moon. But it won't be the last step in our quest to uncover its secrets. The potential for even more advanced missions to Europa could lead to new discoveries and push the boundaries of human knowledge. The search for alien life is part of a broader mission to understand our place in the universe. Space exploration isn't just about discovering other worlds, it's about understanding our own world in new ways. Each mission to Europa, Mars, or beyond helps us answer fundamental questions about life, the cosmos, and our future. As we continue to venture further into space, we are bound to discover new frontiers that challenge our current knowledge and maybe even redefine what it means to be alive. When we think about life beyond Earth, we often picture distant exoplanets orbiting, other stars in far-off galaxies. But what if the key to finding extraterrestrial life is right in our own backyard, hidden beneath the frozen surface of one of Jupiter's moons? That moon is Europa, a small, icy world that has captivated the imagination of scientists and space enthusiasts alike. For decades, Europa has been at the top of the list of places to look for life in our solar system. But what exactly makes this seemingly desolate moon so intriguing? Could Europa hold the answers to one of the greatest questions humanity has ever asked? Is there life beyond Earth? Europa, discovered by Galileo Galilei in 1610, might seem like an unlikely place for life. It's about the size of Earth's moon and is covered by an icy shell that is several miles thick. But here's where it gets interesting. Beneath that ice, scientists believe there could be a vast ocean of liquid water. And if you know anything about life on Earth, You know that water is one of the most important ingredients for life as we understand it. Europa's ocean is believed to be in contact with its rocky mantle, which means that the water could be rich in the essential chemical elements required for life. But there's more. Tidal forces from Jupiter's immense gravity cause Europa to flex and stretch as it orbits, generating heat in the Moon's interior. This heat could create a warm, possibly habitable environment beneath the icy surface, where life might exist, shielded from the harsh radiation of space. So, what would it mean if we discovered life on Europa? Would it be similar to life on Earth? Or would it be something completely different? Could microbial organisms survive in Europa's frozen ocean? Or would we find something far more complex? These are the questions that drive scientists and space. Agencies like NASA and the European Space Agency, ESA, to explore Europa. To understand the potential for life on Europa, we need to take a closer look at the Moon's key features. Europa's ice shell, though thick, is not impenetrable. Scientists have observed strange features on the surface that suggest the ice may be fractured, with plumes of water vapor shooting into space from cracks in the ice. These plumes, first detected by NASA's Galileo spacecraft, are key clues that something is happening beneath the surface. The upcoming Europa Clipper mission, set to launch in the 2020s, will dive deeper into these phenomena, collecting data that could help us understand what's really going on below the surface. But it's not just the surface that's interesting. It's what lies beneath. Europa's ocean could be as deep as 100 kilometers, making it one of the largest subsurface oceans in the solar system. The ocean is kept warm by tidal heating, which occurs as Europa's orbit around Jupiter causes its shape to stretch and squeeze. This process generates enough heat to maintain liquid water beneath the icy shell, despite the freezing temperatures on the Moon's surface. Europa's ocean could have a composition similar to Earth's oceans, but with some significant differences. Scientists believe that the ocean could contain salt water, possibly even salty enough to match the salinity of Earth's oceans. But there's more to it than just water. Europa's ocean is in contact with the Moon's rocky mantle, which means it could be rich in the chemical elements that are necessary for life, such as carbon, nitrogen, phosphorus, and sulfur. These elements, combined with water and energy from tidal forces, could create the conditions necessary for life to emerge. Scientists also speculate that the ocean might harbor hydrothermal vents on the seafloor, similar to those found in Earth's icon, deep oceans. On Earth, these vents provide a unique environment where life thrives, independent of sunlight, relying instead on chemical energy from the Earth's core. If Europa's ocean has similar hydrothermal vents, it could provide a suitable environment for microbial life to survive and even thrive. While the idea of finding intelligent alien civilizations on Europa is exciting, the reality is that if life exists there, it is likely to be microbial in nature. After all, Europa is an inhospitable place, with temperatures plummeting far below freezing on its surface, and intense radiation bombarding its surface from Jupiter's magnetic field. The conditions on Europa would make it difficult for complex life forms to survive. However, that doesn't mean life isn't possible. On the contrary, microbial life could thrive in Europa's ocean. Microbial life on Europa would have to adapt to the extreme conditions beneath the ice. If life does exist, it would likely be similar to extremophiles on Earth, organisms that can survive in the most extreme environments, from the depths of the ocean to volcanic vents, or even inside nuclear reactors. On Earth, life has demonstrated an incredible ability to adapt to the most extreme environments. So it's entirely plausible that microbial organisms on Europa could use the ocean's chemical ingredients to survive, even if they don't rely on sunlight like life on Earth does. In fact, life could thrive in a manner quite different from what we know. On Earth, life is primarily driven by sunlight, with photosynthesis powering most ecosystems. But on Europa, the absence of sunlight means that any life forms would have to rely on other energy sources. This could be chemical energy derived from Europa's ocean, or even energy from hydrothermal vents. Scientists have proposed that these vents could serve as the ideal birthplace for microbial life, as they provide warmth, nutrients, and the right chemical environment for life to thrive. In just a few years, NASA's Europa Clipper mission will embark on a groundbreaking journey to Europa. This mission is designed to answer some of the most pressing questions about the Moon's potential for life. The spacecraft will fly by Europa several times, using its suite of scientific instruments to study the surface, the ice shell, and the ocean below. Europa Clipper will make high-resolution observations of the surface and study the chemical composition of the Moon's water and ice. One of the key objectives of the Europa Clipper mission is to study the plumes of water vapor that have been observed erupting from the surface of Europa. These plumes are a direct link to the ocean beneath, and analyzing them could provide us with valuable information about the Moon's internal structure. The spacecraft will also study the Moon's magnetic field and the interaction between its ocean and the planet's intense radiation environment. All of this data will help scientists determine if Europa's ocean has the conditions necessary for life and whether any signs of microbial life can be detected. Europa Clipper is expected to launch in the 2020s, but it's not the only mission on the horizon. The European Space Agency is planning its own mission to Europa, called the Jupiter Icy Moons Explorer, JUICE. JUICE will study not just Europa, but also Jupiter's other icy moons, Ganymede and Callisto. Together, these missions will help us understand whether life could exist on Europa and provide us with the tools to explore other potential habitats for life beyond Earth. So, what would it mean if we discovered life on Europa? The implications would be nothing short of groundbreaking. First, it would confirm that life is not unique to Earth, and that other worlds in our solar system, and perhaps beyond, could harbor life as well. Europa's discovery would also have profound philosophical implications, challenging our understanding of life and our place in the universe. On a scientific level, finding life on Europa would be a huge leap forward in our search for extraterrestrial life. It would demonstrate that life can emerge in a variety of environments, not just on Earth-like planets with oxygen-rich atmospheres and warm temperatures. This realization could expand the search for life to moons, asteroids, and other celestial bodies that were once thought to be barren. Moreover, the discovery of alien life on Europa could inspire a new wave of space exploration. If microbial life is found on Europa, it could push scientists to explore other moons and planets in the solar system, like Enceladus, Saturn's icy moon, or Titan, another moon of Saturn that has a thick atmosphere and lakes of liquid methane. Europa's discovery could open the door to exploring these other worlds, each with its own unique conditions that might support life. As we embark on the search for life on Europa, we must also consider the ethical implications of such discoveries. Should we colonize Europa if we find life? Or should we protect its pristine environment and study it from afar? These are questions that will need to be addressed as we move forward in our exploration of Europa and other celestial bodies. The future of Europa exploration is exciting, and while we don't yet have definitive answers, we're on the cusp of groundbreaking discoveries. With missions like Europa Clipper on the horizon, we're closer than ever to uncovering the secrets of this icy moon and learning whether it could harbor alien life. Europa, one of Jupiter's 4 largest moons, is a mysterious and captivating world that has sparked the curiosity of astronomers and scientists for centuries. Discovered by Galileo Galilei in 1610, Europa was one of the first moons identified orbiting another planet, a revelation that changed our understanding of the solar system and the cosmos. At first glance, Europa might seem unremarkable. A small, icy moon located 484 million miles away from Earth, orbiting one of the most massive planets in our solar system. But beneath its frozen exterior lies an intriguing world that could hold the key to some of the biggest questions we've ever asked about life beyond Earth. Europa is one of the 4 Galilean moons of Jupiter, alongside Io, Ganymede, and Callisto. These moons are unique because they were all discovered by Galileo, using the newly invented telescope in the early 17th century. Europa, with its smooth, icy surface, stands out among these moons due to the strange features observed on its surface and the tantalizing hints of what might lie beneath the ice. It is the 6th largest moon in our solar system, with a diameter of about 1,140 miles, slightly smaller than Earth's moon. But despite its size, Europa has some of the most fascinating geological features in the solar system. Europa's most striking feature is its icy surface, which appears relatively smooth compared to many other moons and planets. When viewed through a telescope or spacecraft, the surface seems almost flawless, with very few craters. But closer inspection reveals something even more extraordinary: a network of cracks, ridges, and fractures that cover much of the moon's surface, creating a unique and intricate pattern. These fractures suggest that Europa's icy shell is not as rigid as it appears and may be shifting or moving, possibly due to forces from within the moon. The true mystery, however, lies beneath Europa's icy shell. Scientists believe that beneath this surface there is a vast ocean of liquid water. This ocean could be more than 100 kilometers deep, and it is kept warm by tidal forces caused by the gravitational pull of Jupiter. As Europa orbits Jupiter, its orbit is slightly elliptical, meaning that its distance from the planet changes slightly as it travels. This causes the moon to stretch and squeeze as Jupiter's immense gravity tugs at it. This constant flexing generates heat, which could maintain the liquid water beneath the ice, despite the freezing temperatures on the surface. This subsurface ocean has made Europa one of the top candidates in the search for extraterrestrial life. On Earth, life thrives in the depths of our oceans, particularly around hydrothermal vents, where heat and chemicals from the Earth's core create an environment suitable for life to flourish. Europa's ocean, if it exists as scientists believe, could harbor similar conditions: warm, chemically rich water that could provide a perfect environment for life to take hold. This idea has fascinated scientists for decades, prompting multiple space missions aimed at learning more about the moon and its potential for harboring life. Europa's surface, while icy and cold, is also a treasure trove of geological features that hint at the dynamic processes taking place beneath the surface. The fractures that mark Europa's icy crust are not just random. They form intricate patterns that suggest a history of tectonic activity. The presence of these cracks, which extend over large portions of the moon's surface, implies that Europa's icy shell may be floating on a subsurface ocean, allowing it to shift and deform over time. Some scientists believe that Europa's icy shell could be floating atop the ocean like a giant ice raft, with the ocean acting as a lubricating layer. In addition to the fractures, Europa also exhibits features that look like ridges, or double ridges, where the surface has been pushed up, creating raised structures that resemble mountain ranges on Earth. These ridges are believed to have formed as a result of the stretching and compression of the icy surface due to tidal forces from Jupiter. In some areas, the surface appears to have been scraped or reshuffled, which suggests that Europa's icy shell might be moving or rearranging itself over time. This dynamic process could be a crucial clue in understanding the internal workings of the Moon and how its ocean is kept warm and liquid. One of the most fascinating aspects of Europa's surface is the evidence of potential subsurface water activity. In 2013, NASA's Hubble Space Telescope detected water vapor plumes erupting from Europa's surface, similar to the geysers observed on Saturn's moon Enceladus. These plumes appear to be shooting out from cracks in the ice, potentially offering a direct link to the ocean below. If these plumes are indeed connected to Europa's subsurface ocean, they could provide a way for scientists to sample the water beneath the ice without having to drill through the thick crust. This discovery has sparked excitement among scientists, as it could allow them to directly study Europa's ocean and search for signs of life without the need for a lander or complex drilling equipment. Europa's location in the outer solar system, orbiting Jupiter, also plays a significant role in its potential for life. Jupiter, the largest planet in our solar system, exerts an immense gravitational pull on its moons. This gravitational interaction creates tidal forces that heat up the interiors of Europa and its neighboring moons, Io and Ganymede. These tidal forces are especially important for Europa, as they could maintain the liquid ocean beneath its icy crust. Europa's position within the Jupiter system places it far from the warmth of the Sun, which means that its surface is incredibly cold, averaging around 260 degrees Fahrenheit, 162 degrees Celsius. The surface temperature is so low that it is unlikely to support life in any traditional sense. However, the tidal heating generated by Jupiter's gravity provides the necessary energy to keep the ocean below warm and liquid, offering a potential habitat for life even in such an inhospitable environment. Europa is also part of the family of Galilean moons, all of which have unique characteristics. For instance, Io, Europa's neighboring moon, is one of the most geologically active bodies in the solar system, with hundreds of active volcanoes. Ganymede, the largest moon in the solar system, is unique for its magnetic field, while Callisto, another large moon of Jupiter, is considered one of the oldest and most heavily cratered moons in the solar system. Together, these moons provide a fascinating variety of geological and environmental conditions that are valuable for studying the evolution of moons and planets, as well as the potential for life in different environments. Europa's relationship with Jupiter is not just important for its geology, it also plays a critical role in the protection of the Moon. Jupiter's immense magnetic field shields Europa from harmful cosmic radiation, which could otherwise strip away the Moon's atmosphere and make it even less hospitable to life. However, this magnetic field also creates a hazardous environment for any probes or spacecraft that venture too close to Europa. The intense radiation from Jupiter's magnetosphere could pose a significant risk to spacecraft, and it is one of the reasons why missions to Europa must be carefully planned to avoid prolonged exposure to these radiation belts. The possibility of life on Europa has been a major driver behind numerous space missions and studies. In 1995, NASA's Galileo spacecraft became the first mission to extensively study Europa, providing us with valuable data about the Moon's surface and its potential for supporting life. Galileo's observations revealed the unique geological features on Europa's surface and provided evidence that the Moon's ice crust is floating on a liquid ocean, creating the possibility that life could exist beneath the ice. The next major step in our exploration of Europa will be the Europa Clipper mission, slated to launch in the 2020s. Europa Clipper will conduct detailed flybys of Europa, providing high-resolution data on the Moon's surface, ice shell, and subsurface ocean. One of the mission's primary goals is to search for signs of life by analyzing the chemical composition of Europa's surface and plumes of water vapor, if they exist. By studying the composition of Europa's ocean and understanding its interaction with the Moon's rocky mantle, scientists hope to determine whether it has the necessary conditions to support life. The possibility of discovering microbial life on Europa has captured the imaginations of scientists, philosophers, and the general public alike. If life exists on Europa, it would be the first concrete evidence that life is not exclusive to Earth. This discovery could have profound implications for our understanding of biology, evolution, and the potential for life to exist on other worlds. Europa, though covered by a thick, icy shell, holds one of the most exciting scientific mysteries in our solar system: a subsurface ocean of liquid water. At first glance, this moon may seem cold and inhospitable, but beneath its icy crust lies a hidden world. Imagine a vast ocean, not bathed in sunlight, but kept warm by the intense tidal forces from Jupiter's immense gravity. It's like a giant, watery world encased in a transparent, frozen shell, holding the potential to host life in ways we never thought possible. To understand why this ocean is so significant, let's explore what makes it unique. Europa's icy surface is roughly 15 to 25 kilometers thick, but scientists believe that beneath this surface lies an ocean that could be as deep as 100 kilometers. This ocean, unlike Earth's oceans, isn't warmed by the sun, but by tidal heating. Tidal heating occurs when Europa's orbit around Jupiter isn't perfectly circular, which causes the Moon to stretch and squeeze as it moves through Jupiter's powerful gravitational field. This stretching causes internal friction within the Moon, generating heat, much like the heat produced when you rub your hands together rapidly. This tidal heating could be enough to keep the subsurface ocean warm and liquid, despite the freezing temperatures on Europa's surface. But it's not just the ocean itself that makes Europa so intriguing. It's what lies in that ocean. The true possibility of life in such an environment has become one of the most exciting aspects of Europa's exploration. On Earth, life has been found thriving in the most extreme environments, from the deepest parts of the ocean to the frigid reaches of Antarctica. In these remote locations, life doesn't rely on sunlight, but on chemical energy from the Earth's interior. If Europa's ocean is similar to Earth's deep ocean habitats, it could harbor microbial life that doesn't need sunlight to survive, drawing energy from chemical reactions between the ocean and the rocky mantle beneath. Imagine an underwater volcanic vent, spewing hot, mineral-rich water into the icy depths. On Earth, such vents host diverse ecosystems, teeming with life forms that thrive without sunlight. If Europa's ocean has similar hydrothermal activity, it could provide a refuge for alien life forms. It's a tantalizing possibility that could change our understanding of what life can look like and where it can exist in the universe. One of the most exciting discoveries about Europa is the detection of plumes of water vapor erupting from the Moon's surface. These plumes, observed by NASA's Hubble Space Telescope in 2013, offer a potential way for scientists to sample the subsurface ocean without drilling through miles of ice. Think of them as geysers, shooting up from the Moon's icy crust, carrying, with them, a small piece of Europa's hidden ocean. These plumes are not just fascinating for their visual beauty. They could hold the key to unlocking the secrets of Europa's ocean. By studying the composition of these plumes, scientists could analyze the water beneath Europa's ice shell and search for signs of life or essential chemical ingredients. It's like finding a window into an otherwise impenetrable world, one that could be teeming with life or contain the building blocks of life as we know it. The plumes are believed to originate from cracks in Europa's icy crust, where the pressure from the subsurface ocean forces water up to the surface. These cracks may serve as an escape route for material from the ocean below, and the plumes could contain salts, minerals, and organic molecules. ingredients that are essential for life. The discovery of these plumes has sparked excitement among scientists as they could allow for the first direct sampling of Europa's ocean without the need for a lander or drilling mission. Europa Clipper, the upcoming NASA mission to Europa, is designed to study these plumes in more detail. The spacecraft will conduct flybys of the Moon, collecting data on the water vapor and its chemical composition. If the plumes are indeed connected to Europa's ocean, the spacecraft will be able to analyze them and look for signs of life, helping us determine whether Europa could be a cradle for alien organisms. Europa's surface is a strange and beautiful world of its own, marked by cracks, ridges, and complex patterns. The icy shell that covers Europa is not a static, unchanging surface. It is constantly being reshaped and reworked by forces beneath the ice. This dynamic surface is a result of the tidal heating generated by Jupiter's gravity. As Europa orbits the gas giant, its shape changes, causing the ice shell to flex, stretch, and compress. One of the most striking features on Europa's surface is its complex network of cracks and ridges. The fractures on Europa are not random. They form intricate patterns that suggest a history of tectonic activity. These cracks indicate that Europa's icy shell may be floating on a subsurface ocean, and the motion of the ice could be evidence of the movement of liquid water beneath. Some scientists believe that Europa's surface may be shifting like a giant ice raft, with the ocean beneath acting as a lubricating layer. This means that the surface of Europa could be constantly rearranging itself, creating new geological features over time. In addition to the fractures, Europa's surface also contains strange ridges and double ridges, where the ice has been pushed up, creating elevated structures that resemble mountain ranges on Earth. These ridges are believed to have formed as a result of the stretching and compression of the ice shell caused by tidal forces. These dynamic geological features provide scientists with valuable clues about the internal processes taking place on Europa and how its ocean and ice interact. Europa's surface is also dotted with large, smooth areas that appear to have been resurfaced relatively recently. These regions, known as smooth plains, are believed to be relatively young and may have been created by the movement of ice or by the upwelling of material from the subsurface ocean. The presence of these smooth plains suggests that Europa's surface is constantly being reshaped by processes beneath the ice, making it one of the most geologically active bodies in the solar system. Despite Europa's potential for harboring life beneath its icy shell, the surface environment is far from hospitable. The intense radiation from Jupiter's magnetic field bombards Europa's surface, creating a harsh environment for any potential life forms. The radiation levels on Europa are so high that they could sterilize the surface, making it nearly impossible for life to survive on the Moon itself. This radiation, however, does not penetrate the icy shell, and it is believed that any life forms in the subsurface ocean would be shielded from this harmful radiation. Jupiter's magnetic field also plays a crucial role in Europa's protection. While the radiation from Jupiter's magnetosphere is harmful to the surface, it also helps shield Europa's interior. Europa orbits within Jupiter's immense magnetic field, which protects it from the full brunt of cosmic radiation. This magnetic field, coupled with the thick ice shell, creates a protective barrier that could allow life to exist in the ocean beneath. The radiation environment is one of the primary reasons why missions to Europa must be carefully planned. Spacecraft that venture too close to Europa must navigate the intense radiation belts around Jupiter. For example, NASA's Europa Clipper mission will make several flybys of Europa, but the spacecraft will not remain in the radiation zones for extended periods. Instead, it will use gravity assists from Jupiter's other moons to minimize its exposure to the radiation, while still gathering crucial data about Europa's surface and subsurface. The upcoming Europa Clipper mission, set to launch in the 2020s, will be the first spacecraft dedicated to studying Europa in detail. This mission will perform flybys of Europa, studying its surface, ice shell, and subsurface ocean from a distance. Europa Clipper will use a suite of scientific instruments to analyze the Moon's composition, temperature, and geology, and will investigate the potential for life in Europa's ocean. Europa Clipper's primary goal is to understand the Moon's potential for habitability. The spacecraft will look for signs of water vapor plumes, study the chemical composition of the Moon's surface, and analyze the thickness of its icy shell. By gathering this data, scientists hope to determine whether Europa's ocean could support life and what conditions might be necessary for that life to thrive. Europa Clipper will also be equipped with instruments to study Europa's magnetic field and analyze the interaction between the Moon's ocean and Jupiter's powerful radiation environment. The mission will provide critical data that could help scientists understand the potential for life on Europa and other icy moons in the outer solar system. Despite the tremendous progress scientists have made in studying Europa, there are still some mysteries that remain unsolved, particularly when it comes to the Moon's icy shell. For years, we've known that Europa's surface is marked by strange cracks, ridges, and features that suggest a dynamic and complex interior. However, one major question still looms. How thick is Europa's ice shell? And what exactly is going on beneath it? Europa's surface is believed to be made up of a thick layer of ice that covers a liquid ocean, but the thickness of this ice layer remains a topic of heated debate. Some studies suggest the ice could be as thin as 15 kilometers, while others believe it could be up to 30 kilometers thick. This uncertainty is a significant obstacle for scientists trying to understand how Europa's subsurface ocean works. If the ice is too thick, it could be difficult for heat and material from the ocean to escape, potentially making the environment less conducive to life. On the other hand, if the ice is too thin, the ocean could be in direct contact with the surface, potentially making it more vulnerable to contamination from external factors, such as the intense radiation from Jupiter's magnetosphere. The variability in the thickness of Europa's ice shell is also tied to another mystery: the Moon's overall geological activity. The presence of fractures, ridges, and areas of resurfaced ice suggests that the ice shell is not static, but constantly being reshaped and reworked. The exact mechanism behind this activity remains unclear. Some scientists believe that tidal heating could be causing the ice to move and deform, but others suggest that there could be additional processes at play beneath the surface. Could there be massive plumes of water pushing against the ice, causing the surface to shift? Or are there other, as yet undiscovered forces at work? The Europa Clipper mission, set to launch in the 2020s, may provide the answers to these questions. With its suite of advanced instruments, the spacecraft will study the Moon's ice shell in greater detail than ever before, helping scientists unlock the secrets hidden beneath the surface. But, for now, the precise nature of Europa's ice shell remains one of the biggest unresolved mysteries of the Moon. One of the most tantalizing discoveries made about Europa in recent years is the detection of water vapor plumes erupting from the Moon's surface. These plumes, observed by the Hubble Space Telescope, have the potential to offer a direct link to Europa's subsurface ocean, but there are still many unanswered questions about their origins and composition. While scientists have confirmed the presence of these plumes, what remains unclear is whether they are truly connected to the ocean beneath Europa's icy surface. Are these plumes just surface-level phenomena, or do they tap into the vast liquid ocean below? Some researchers believe that the plumes are a result of pressurized water from the ocean forcing its way through cracks in the ice shell, creating geysers that reach into space. If that's the case, the plumes could offer scientists a unique opportunity to sample Europa's ocean without needing to drill through the thick ice. However, others are more cautious, suggesting that the plumes may not be directly connected to the ocean at all. Could they be the result of surface-level processes, such as the sublimation of ice due to radiation from Jupiter's magnetic field? Or perhaps they are caused by some other unknown mechanism? The upcoming Europa Clipper mission is poised to answer these questions by conducting detailed flybys of the Moon, analyzing the composition of the water vapor plumes, and determining whether they indeed originate from Europa's subsurface ocean. Until then, the plumes remain an intriguing mystery that could provide the key to understanding Europa's internal processes. Another major anomaly surrounding Europa is its magnetic field. Unlike Earth's magnetic field, which is generated by the motion of molten iron in the planet's core, Europa's magnetic field appears to be induced by Jupiter's powerful magnetosphere. This means that the magnetic field detected on Europa is not generated internally, but is rather the result of interactions between the Moon and Jupiter's immense magnetic field. However, this induced magnetic field has raised some puzzling questions. Scientists had originally expected that Europa's ocean would be electrically conductive due to the presence of salt water, which would allow the Moon's magnetic field to interact with the ocean. But the measurements taken by NASA's Galileo spacecraft have suggested that the magnetic field is much stronger than expected, indicating that there could be more going on beneath the surface than we initially thought. 1. Possibility is that Europa's ocean might be more complex than we realize. Could there be an underlying layer of material, such as a conductive mineral or a different type of salt, that is altering the way Europa's magnetic field interacts with its subsurface? Or could there be additional layers beneath the ocean, perhaps a layer of ice or even a rocky crust, that is affecting the magnetic field readings? The exact nature of Europa's magnetic field remains an unresolved mystery, and understanding it could provide key insights into the composition and structure of the Moon's interior. Europa Clipper will also investigate this mystery by conducting detailed measurements of the Moon's magnetic field during its flybys. By studying how the magnetic field changes over time and in response to different conditions, scientists hope to learn more about the ocean beneath Europa's ice and gain a clearer picture of what is happening deep within the Moon. Europa's ocean is one of the most intriguing features of the Moon, but its origins remain shrouded in mystery. How did this vast liquid ocean form in the first place? And how has it managed to stay liquid for so long despite the freezing temperatures? On Europa's surface, one popular hypothesis is that Europa's ocean formed early in the Moon's history, during a period of intense heat and tidal forces. As Europa orbited Jupiter, the gravitational interactions with the massive planet could have caused the Moon's interior to heat up, creating a subsurface ocean that remained liquid even as the surface cooled. Over time, this ocean could have become trapped beneath a thick layer of ice, which acted as a protective shield, keeping the water from freezing completely. But there are still unanswered questions about the formation of Europa's ocean. Could it have formed through some other mechanism, such as the collision of icy comets or the impact of high-energy radiation from Jupiter? How did the ocean become so deep and extensive, and why has it remained liquid for billions of years? Some scientists have even proposed that Europa's ocean might be replenished by internal heat from the Moon's rocky mantle, which could continuously cycle water in and out of the ocean. But the details of this process remain uncertain, and Europa's ocean's origins continue to puzzle researchers. Europa Clipper will hopefully provide new insights into the formation of Europa's ocean by studying the Moon's surface and magnetic field in greater detail. Understanding how the ocean formed and how it has persisted over time could provide critical clues about the Moon's history and its potential for supporting life. Perhaps the most profound mystery surrounding Europa is the possibility of life beneath its icy shell. Scientists have long speculated that Europa could harbor microbial life, but this remains one of the biggest unanswered questions in planetary science. What if we do find life on Europa? How would we recognize it, and what would that mean for humanity's understanding of life in the universe? While many scientists are optimistic about the possibility of finding life on Europa, others remain cautious. Could the conditions on Europa be truly suitable for life? Or is it too hostile an environment for any organisms to survive? Even if life does exist, how would it compare to life on Earth? Could it be based on biochemistry that is completely different from what we know? Or is it more similar to Earth's extremophiles, which thrive in extreme conditions? If life is discovered on Europa, it could change the course of science forever. It would force us to confront fundamental questions about the nature of life, its origins, and its potential to exist elsewhere in the universe. But even if life is never found, the search for it could yield profound insights into the potential for life on other moons and planets. And it could bring us closer to answering the ultimate question: are we alone in the cosmos? Imagine standing at the edge of the unknown, looking out at the vast expanse of space, and suddenly, an unexpected discovery shatters everything you thought you knew about life in the universe. It's a feeling of awe, wonder, and even disbelief. That's what scientists experienced in the late 2010s when, after decades of study and exploration, new findings began to suggest that Europa, Jupiter's icy moon, might not just be a frozen, barren world. What if this distant moon harbors a secret that could change everything? What if life, in some form, really exists there? And what if this life is not so different from our own? The most shocking revelation came in the form of Europa's plumes, plumes that burst from its icy shell, shooting water vapor and organic molecules into space. These jets, first detected by NASA's Hubble Space Telescope in 2013, were more than just spectacular visuals. They were potential portals to Europa's vast, hidden ocean. Think about it. These plumes could offer humanity its first-ever glimpse into a distant, alien world without drilling through miles of thick ice. We could sample the very ocean that may hold microbial life, or at least the ingredients necessary for it. These plumes were the moment that truly changed the way we saw Europa, turning what was once a cold, lifeless moon into a living, breathing entity, one that could, just perhaps, harbor life. Imagine standing in the control room of NASA, watching as data from the Hubble Space Telescope streams in. The readings show something incredible: bursts of water vapor, potentially rich with salts, minerals, and organic compounds. Could these plumes be the smoking gun of a habitable environment? Beneath Europa's ice shell, it's one thing to theorize that life could exist on Europa. It's another to actually detect signs that point to the potential for life. Could we be on the brink of discovering that we are not alone in the universe, that life exists in the most unexpected places, and that the answer might not lie on distant exoplanets, but right in our own solar system? What makes this revelation even more striking is the way it disrupts everything we've assumed about life's requirements. For centuries, we believed that life could only exist in environments similar to Earth. Warm, sunny planets with liquid water on the surface. But Europa's ocean is far from ideal by traditional standards. The surface temperature is freezing, and the ice shell is miles thick. Radiation from Jupiter bathes the surface in harsh, lethal doses. But beneath this icy exterior, the ocean is kept warm by tidal heating, a process that stretches and compresses the Moon as it orbits Jupiter, generating enough heat to keep the water liquid. This discovery suggests that life may not require sunlight or Earth-like conditions to thrive. It could adapt and survive in the most extreme environments. This is where the true drama unfolds. The discovery of these plumes was the moment when Europa transitioned from an abstract idea into a tangible possibility. It was no longer a far-off dream, but a real target for exploration and discovery. With the Europa Clipper mission now on the horizon, this revelation has only heightened the stakes. The spacecraft will fly by Europa multiple times, gathering data, analyzing the surface and subsurface, and perhaps even collecting samples from the very plumes that have sparked so much excitement. The anticipation is palpable. Could the Europa Clipper mission provide the breakthrough we've all been waiting for? Could it bring us the first signs of alien life in our solar system? The excitement surrounding Europa is not just about the possibility of microbial life. It's about what this discovery means for humanity's search for life beyond Earth. For years, scientists have been looking to distant exoplanets in the habitable zone, the region around a star where liquid water could exist, as the most promising places to search for life. These exoplanets are hundreds, if not thousands, of light-years away. But Europa is right in our own backyard, orbiting Jupiter, just 484 million miles away from Earth. If life can exist in Europa's subsurface ocean, then perhaps life is more common in the universe than we ever imagined. The implications are mind-blowing. What if we discover microbial life on Europa? Would it confirm that life is not a unique phenomenon tied to Earth's conditions, but rather a more universal characteristic of the cosmos? Such a discovery would change everything we know about biology, evolution, and the origins of life. If life exists on Europa, it might mean that life is far more widespread than we thought, lurking beneath the icy surfaces of moons and planets across the universe. Europa could be the key that unlocks an entirely new understanding of life and its ability to exist in the most extreme environments. But the questions don't stop there. If life is found on Europa, what kind of life would it be? Would it be similar to Earth's extremophiles, organisms that thrive in conditions of extreme heat, cold, or radiation? Or would it be something completely different, an alien form of life that doesn't rely on the same biochemical processes as life on Earth? Could it be possible that life on Europa is based on completely different building blocks, or does it share similarities with the life we know on Earth? These questions raise an even more profound mystery. What if Europa's life is not just microbial, but something more complex? Could it harbor intelligent life, or at least more complex organisms that have evolved to survive in this extreme, isolated world? The idea seems almost too fantastical to consider, but it's not out of the realm of possibility. The discovery of microbial life on Europa would forever change our understanding of the conditions that allow life to thrive, while the discovery of more complex organisms would shake the foundations of biology itself. Europa could be the first place where we truly encounter extraterrestrial life, something that has never been seen before. The revelation that Europa could harbor life beneath its icy surface forces us to reconsider our entire approach to space. Exploration. For decades, we've focused our search for life on Earth-like planets orbiting distant stars. But what if life doesn't need a planet at all? What if life can survive in the cold depths of an alien ocean, without sunlight, in a world unlike anything we've ever imagined? Europa forces us to think outside the box, to challenge our preconceived notions of what life can look like and where it can exist. As we continue to explore Europa, we might discover even more mysteries, things we never thought possible. For example, could there be other moons in our solar system that share similar characteristics to Europa? Could they also harbor hidden oceans? And could they have life, too? What if Europa is just the first in a series of discoveries that reveal that moons, not planets, are the true hotspots for life in the universe? The possibilities are endless, and with each discovery, the EB stakes continue to rise. The Europa Clipper mission, due to launch in the coming years, could be the next great step in answering these questions. The spacecraft is equipped with cutting-edge technology that will allow it to study Europa in unprecedented detail, examining its ice shell, its subsurface ocean, and the possibility of life within. The mission will search for organic molecules, analyze the plumes, and gather data that could provide the first hard evidence that Europa's ocean harbors the conditions necessary for life. As we reach the climax of this journey into the unknown, the future of Europa's exploration holds the promise of something truly groundbreaking. With each passing day, we come closer to answering the ultimate question: is there life beyond Earth? Europa's plumes and subsurface ocean are only the beginning. The future of space exploration is full of mystery, and Europa is one of the most intriguing puzzles in our solar system. Could it harbor life, or will it remain an enigma forever out of reach? As we prepare to launch the Europa Clipper mission, the tension builds. The answers are closer than ever, and the discoveries that lie ahead could forever change our understanding of the cosmos. One thing is certain: Europa's secrets are waiting to be uncovered, and the revelation of life, or the potential for life, on this icy moon will be one of the most profound discoveries in the history of humanity. The universe has always been full of wonder and mystery, but now Europa offers us a chance to rewrite the rules of life in the cosmos. What we find there could spark the next great chapter in our exploration of the stars. The question is no longer whether there's life elsewhere, it's how soon we'll find it. From its eerie icy surface to its mysterious plumes of water vapor, Europa has fascinated scientists for decades. What began as a distant, unassuming moon of Jupiter has now emerged as one of the most promising places to search for extraterrestrial life in our entire solar system. Europa's potential to harbor life beneath its thick, icy shell has captured the attention of space agencies and scientists around the world as new discoveries continue to unfold, revealing that this moon may not be as barren as once thought. We've explored the possibility of life on Europa through its subsurface ocean, a vast, liquid world hidden beneath miles of ice. The discovery of this ocean, kept warm by tidal heating from Jupiter's powerful gravitational forces, makes Europa one of the most fascinating targets for life in the cosmos. Scientists have even proposed that life could thrive in this ocean, in conditions similar to the extreme environments on Earth where life exists without sunlight, such as deep-sea hydrothermal vents. Europa's potential to harbor microbial life is not just a thrilling concept. It's a possibility that could reshape our understanding of biology and the very nature of life itself. Then there's the revelation of Europa's plumes, those dramatic eruptions of water vapor shooting from the moon's surface, offering tantalizing glimpses of what lies beneath. These plumes have become one of the most exciting developments in Europa's exploration, as they could allow us to sample Europa's ocean without drilling through the thick ice shell. Imagine the implications of finding organic molecules or even signs of life in these plumes. Europa has gone from a cold, lifeless rock in the sky to a living, breathing entity that could very well hold the key to one of humanity's most profound questions. Are we alone in the universe? Of course, there are still mysteries that remain unresolved. The exact nature of Europa's ice shell, how thick it is, what lies beneath, and how it interacts with the ocean is still an open question. How do the plumes connect to the ocean below? Could there be more than just microbial life beneath the surface? And what about the magnetic field, which hints at complex processes happening deep within the moon? Europa is a world of contradictions and possibilities, and it's clear that the answers we seek will require further exploration and time. But perhaps the greatest mystery of all is the one we haven't yet answered. Is there life on Europa? Every discovery, every new piece of data brings us closer to the truth. The upcoming Europa Clipper mission promises to answer many of these questions by providing high-resolution images and data that could confirm what scientists have long suspected. Europa could be teeming with life, or at the very least, the perfect environment for it. We may be on the verge of a groundbreaking revelation that could change the way we think about life in the universe forever. What do you think? Could Europa be hiding life beneath its icy surface? Do you believe that microbial organisms could thrive in its subsurface ocean, or is there still more to learn about this mysterious moon? We'd love to hear your thoughts. Drop your comments below, and let us know how you think Europa could change the way we explore life in the cosmos. And don't forget to hit that like button if you enjoyed this deep dive into Europa's mysteries. Make sure you subscribe to our channel for more exciting space exploration content, and ring the notification bell so you never miss an update. As we continue to unravel the mysteries of our solar system, we'll keep you in the loop with the latest discoveries.